Hello, for this part, we'll discuss additional examples on how to determine relative extrema of a function by the virtue of the first derivative test. And we have these set of examples given below. So for the first part, we are to find the relative extrema of the given functions, and we are to create a sign table that will summarize the intervals for which they are increasing or decreasing. Similarly, we are given another function wherein our only task is to determine which interval or intervals is this function decreasing. Okay. Now let's consider this function. F of x equals 2x to the fifth minus 5x to the fourth minus 10x cubed plus 7. This was the original intention for the problem. And let us create a table of signs so that we could summarize when is this function increasing and when is it decreasing, and which points are or can be considered as relative extrema. Alright, so what we do here is we need to find the critical points by finding the zeros of its derivative. That is, the derivative of f is equal to 10x to the fourth, correct, minus the derivative of the second term is 20x cubed, and for the third term its derivative is 30x squared plus 7. The derivative of 7 is just 0, and this is 0 whenever we have this equation. Let's observe that we can factor out 10x squared as a common monomial factor for each terms. Tama? That is, upon factoring 10x squared, we obtain x squared minus 2x for the second term minus 3 for the third term, which is equal to 0. Simplifying this further, this becomes 10x squared multiplied to the factors of this quadratic factor inside. This is factorable as x minus 3 and x plus 1. And this is equal to 0. Do you follow? That means we have 3 candidates to be critical points. Those are whenever x is 0, whenever x is positive 3, and whenever x is negative 1. So before we decide which really are critical points here, so tanggalin na lang natin mamaya kapag merong wala, alamin muna natin yung domain ni f. Recall that this is a polynomial function, which means that the domain of this function is the set of all real numbers. That means these 3 candidates are indeed critical points. Again, what do we do here is we line it up in a natural manner in a number line. Tama? That means we'll go first with negative 1, and we'll have 0 here and positive 3 over here. We'll put f prime here to denote that we are to find the sign of f prime on the intervals around these critical points. We know that f is continuous at these critical points, so that's why we put a solid vertical line here para alam natin kasama sila sa conclusion later. Then what's left for us to do is to determine the signs of the following intervals. So what we do here is we use test points from the left and from the right of our critical points, and with that we'll use the sign of that test, the derivative at that particular test point, to conclude for the sign of the derivative over that interval. That is, say for the first one, if we use negative 2 as a test point, let's plug it in to the simplified form of f prime of x. We can get away with these first 2 factors So let's focus on these factors. So negative times negative is positive. So we'll get a positive sign at the left of negative 1. Now let us obtain a number from between negative 1 to 0. Say negative 1 half. If we plug in negative 1 half to x minus 3 here, what's the sign? The sign is still a negative number. If you plug in negative 1 half to this factor here, the sign becomes positive 1 half. So we'll have a negative times positive for the second column here. So what's negative times positive? That is a negative number. Alright, do you follow? Now let's move on to the third column. We need to obtain a number from 0 to 3, say when x is 1. When x is 1, let's plug it inside these two guys here. So we'll have 1 minus 3 is negative times 1 plus 1 is positive. That's why we'll have a negative times positive, and that is still a negative sign. Lastly, let's obtain a number from the right of 3, say 4. If we plug in 4 in these factors, we'll have positive for the first one and positive for the second one as well. That means after 3, the sign of the derivative is positive. Do you follow? So from this table, we can now conclude on which intervals is f increasing and which intervals is f decreasing. And then we can use the first derivative test to determine at which values of x will the function f will have a relative extrema. Okay? So the conclusions, we can initially get are the following. Okay, what's the first one? We know that f is increasing over these intervals. So that means we can say that f is increasing over the intervals negative infinity up to negative 1. We include negative 1 because f is continuous at negative 1. Also, it is increasing over the interval 3 to positive infinity. Do you follow? For the next one, we can conclude on which intervals is f decreasing. So from above, we can conclude that f is decreasing over the intervals, negative 1 to 0 and 0 to positive 3. But since f is continuous at 0, we can say that f is decreasing over the entire interval negative 1 to 3. Okay? Lastly, we can now use the first derivative test to conclude on the relative extrema of this function. Recall, paano nga tayo mag-conclude ng relative extrema? The best thing you can observe is that if you know the signs before and after C, say we have this one and these cases, you can imagine what happens before and after C. Tama? So, in summary, if before C you are decreasing and after C you are increasing, then what can you conclude about C? Tama? Naturally, you can say that f has a relative minimum at C. And that's the interpretation of the first derivative test. Tama? Similarly, if you are increasing before C and after this critical point you decreased, then you are at a relative maximum. But if nothing happened, say you are increasing before C and you are still increasing after C, then no relative extrema occurs at that critical point. And if you are decreasing before C and decreasing even after C, then again, you can observe that there is still no relative extrema at that critical point. So going back to our discussion, what can we say about the critical points -1, 0, and 3? Before -1, you are increasing, and after -1, the function f is decreasing. That means f has a relative maximum at x equals -1. Alright? How about at x equals 0? So you are decreasing at before x equals 0, then but even after that, f is still decreasing after 0. That means f has no relative extrema at 0. If that happens, we can opt not to write it down, but in this case, let us put it down as well just to take note of that. Has no relative minimum at the critical point, or relative extrema at the critical point x equals 0. Do you follow? Then lastly, for this critical point, you are decreasing before 3, but after 3 you are increasing. So what can you say? What can you say is f has a relative minimum at x equals 3. Okay? Yeah, so that's it.